So enjoy the session. Thanks again for joining, and ball's over to you, Andy.
All right, you got it. So first and foremost, my name is Andy Crandall. I am one of our identity leads here in the Americas. You can think of me as sort of a lead solutions architect, and I cover everything from Canada down to South America as well. I'm here to talk about agentic runtime security today. I've got a few slides I'm going to take you through. I love this stuff, and I end up talking fast, so I should be able to fit all of this into about 25 minutes. We're gonna see what we can do. So let's go ahead and jump right into it. So I have a lot of conversations with clients, and what I find is that there are two main problems that organizations are facing out there when it comes to AI agents, right? One is, how do I secure the agents and the identities that I do have running in my environment that I know about, and I want to sort of empower my workforce to be able to leverage the power of AI to get that sort of exponential capability growth. And then the second is, okay, cool, that's great. Now I have these controls for the things I know about, but how do I understand what's being used across the entire organization? Some might argue that observability is sort of the initial step you got to take to get an understanding of what exists there. But I'm going to show it to you in this order today, so that's why I have them 1 and 2. But those are the two main things I'm going to focus on. So let's lay out the problem for a second, right? AI agents are not like humans. They're also not like machine identities. You can almost think of them like, I kind of call them like, like a silly contractor, right? Who moves at machine speed. So they're going to make decisions. Those decisions are not always the best decisions, but they're going to try to take a look at as much information as they have available to them to make contextualized decisions based on the prompt that they were given. So traditional IAM controls don't necessarily scale well to this type of behavior at machine speeds. Not to say that the capabilities haven't existed to provide this level of control, but you could say the juice hasn't always been worth the squeeze to move towards a more zero trust identity architecture that can provide that contextual decision making at the actual runtime, right? So what we need is we need to improve our controls there, and then we need to get ahead of it, because the scale and the sprawl at which these technologies are improving is incredible. I have never seen in my entire career a technology that, one, inspires so much innovation, but also inspires so much anxiety, because people feel like they're being left behind. So people are adopting these technologies at a rate that I have never seen before. So we need to get ahead of this and start thinking about what policy we want to implement so that we can have controls that are in place to actually secure our organizations. So I talked a bit about the challenge, but what are the actual risks here, right? One, we've got overprivilege without visibility. So organizations are just handing tokens over. They're saying, all right, cool, I need you to do this for me, so just use my credentials, right? Log in as root. Do the things I need you to do, and I'm just going to hit approve because I'm tired of reading these things. There's no real-time enforcement. I don't have the ability to actually take a look at that at the last mile, right? And say, do I really have access to this target system? Am I doing this fine-grained authorization at the actual point of access? Do I have the ability to delegate, right, from a user, right? Even if I'm doing agent to agent flows, there is a person at the tail end, at the beginning, right, that said, I need you to kick off a task, right? So I need to be able to provide a delegation chain, and I don't want to do impersonation. Impersonation is very bad because to each of the systems, right, it is the end user doing those things, when in reality it's an AI agent. It breaks the accountability chain. No AI agent is going to stand up in court and testify as to why they dropped production database tables, right? And then, sort of back to the final point there, right? Like shadow models and access, we need observability to be able to provide a view into the things that are being spun up. So I've spent some time explaining the problem. How do we actually solve this issue? Step one, right? Register every model and every agent. So every agent needs to have an identity. There's a bunch of ways you can do this, right? Whether that's SPIFFE, federated workload identities, X509 certificates conducting mutual TLS. agent registries, right? There's a bunch of ways to do this, but we need some way to issue what's considered a birth certificate, right, to your AI agents. That identity, though, should give them no actual permissions to do anything. And I'll show you this in our demonstration, right? Where we have an initial identity that can be issued, but it shouldn't allow it to do anything. The only time that we're going to give explicit permissions is when we have intent communicated, right? That the model intends to do something on behalf of a user, or that the agent, right, intends to do something on behalf of a user. So we will tie actions to the intent. That will allow us to basically provide very specifically scoped credentials for a period of time, and then we will enforce those at the point of use, right? So I will show you that as well, right? How we're actually building a dynamic authorization framework, right? That allows for us to enforce access all the way down to the specific access control point. And then finally, we need proof of control, right? I need to be able to provide a cryptographically validatable flow, right, from start to finish. I'm a user who kicked off this task, and it went, here, here, and here, and inevitably did this thing, right? So I need to be able to provide that chain of control and evidence to do a true audit trail. So what does this look like in practice? And this is what I'm going to show you guys here at a logical level. Basically, we've got a user base, right? We're going to be logging in with a modern through a modern IDP. They're going to hit an AI application. That AI application has, an AI agent on the back end that is interfacing with an MCP server. There is a token management layer in play here. So there's basically, the identity provider and a secrets vault are providing a very translation mechanism for the AI agent to get one, tokens on behalf of a user, and two, to be able to get specific last mile credentials as they're sort of getting specific access. And then all of that is sort of wrapped by observability so that we can see what's really happening at the end layer. So I'm going to jump into we're going to increase the fidelity and the resolution here. Continue to sort of zoom in before I show you the demo, because I think it's helpful to kind of understand that depending on the level of assurance that is required. So, for example, we'll get there. But step one, let's provide an agent and identity, right? The AI agent, right, in this case, right, can use Vault. If the agent needs to do a translation, right, we can establish that initial identity with MTLS, Spiffy, Cloud Identity. It doesn't really matter. One of the benefits of using something like Vault is that it is a token translation engine, right? Or an identity translation engine. And one of the things that it's great at is taking lots of different identity sources and translating that through policy into individual accesses and dynamic credential management, right? So what we're saying here is if I've given my AI agent an identity or I've registered it using the Agentic registry functionality, I can then provide policy that gives it access to specific systems. So what's that look like in real life, right? Looks something like this. We've got Alice. Alex accesses an application. But as I was saying before, the level of control required is directly proportional to the assurance level of the information the agent needs, right? And so as we are building out our security policies and as we are building out the mechanisms in which we're going to require our agent get access to the sensitive information in our systems, we need to sort of take into account that level of risk. So for simple, non-personalized, read-only information, maybe this is like internal documentation, right? Or something that's not tied to a user or sensitive. We can just take that initial identity, we can exchange it with Vault, and we can then provide a one-time use token. Now, the benefits here are it's been proven time and time again that you can basically kick a AI agent in the face and it will expunge its context window, right? Like there are a number of ways that you can exploit and send weird information to get an agent to basically give you information that is within its context window. So things like long-lived tokens, standing privileges, right, can be compromised if anyone gets access to your AI agent. So what you really don't want is a long-lived shared credential being leveraged by this agent that Alice can use, especially if that credential is privileged. Because if Alice sends the right combination of prompts, she's going to get that token back and be able to leverage it for other nefarious purposes. Instagram had a great example of this relatively recently, where the attackers basically socially engineered the AI agent to change the email address to certain accounts to their own email address. So there needs to be guardrails around this, right? Anyway, what is a oops, my apologies. What is a better flow is to use Vault, right, to issue these short-lived dynamic credentials. So even in the event that they are expunged from the context window, we don't have the ability to use them for anything else, right? They're short-lived, they're minimally permissioned, and they are specific to the task that was requested. So let's bump one level up in complexity, right? We've done simple read-only data. How about personalized information that's tied to a user? Here we're talking user context and consent is required. So I've got two different users. They're requesting information about their own accounts. Alice, for example, wants to know her specific account information, right? The agent now needs to tie this to a user. We're using what's called on behalf of flows. This seems to be a pretty common convention in the industry, right? Seem to be aligning around OBO, but on behalf of is a mechanism from the token exchange standard that generally is for delegated permissions, but we're using it to provide specific context into the fact that the agent can operate on Alice's behalf and that it can get access to Alice's specific information, right? So when I, as an AI agent, right, do a token exchange, and I'll show you this and explain it, the flow here is, Alice kind of logs in through her UI, asks the agent to do a task. The agent says, okay, cool. I will take Alice's token and I will take my token and I will do a token exchange against verify in this case to get a specific token that says I am allowed to act on Alice's behalf. There are some controls in place that specifically enforce that that agent is allowed to operate on Alice's behalf, but verify is doing that policy evaluation. Once that's done, right, we can then issue a specific token that says, okay, when you go to Vault, give me a very specific token that is allowed to access Alice's information. So that's sort of one step higher. Let's go even one step further, right? And this is sort of like the grand level of control here. So now what we need is we're going to do something that is sensitive enough that I want to do a human in the loop flow. So what does that look like, right? It's the same flow that we were just talking about, but now I want to provide what's called context, right? So now when I request access, we're going to use what are called rich authorization request flows to be able to provide specific information about what the agent is trying to do to actually evaluate policy against it right in the runtime, and then issue a very specific credential that can be used within Vault to do dynamic authorization, right? So that flow again, Alice requests, we'll say, to transfer $500 from checking to savings. That's the example I'll show you. But just to add a point, right, that could be any use case, right? It could be, I want to change a password in an IBM mainframe. It could be, I want to have you perform database maintenance. And then the rich authorization request, right, when the agent does the token exchange, it says, I want to transfer $500 or, change a password in an IBM mainframe. And then we're able to evaluate policy against that request based on that authorization and the user's details, and send a challenge to the mobile device to actually do a human in the loop flow. Once that is approved, then the token exchange becomes successful, and we're issuing a specific token that can be used for a specific action.